and I'm Chris, and today I'll be talking about E2E tests for autonomous driving software. So, disclaimer: this is not really a session that is trying to teach you something. It's more of a interesting case study, I think, or use case for most of you, because it is not really the typical SaaS industry, but is actually in the autonomous driving industry, which I think is quite different to most of the SaaS products. So here we go. A little bit of self-introduction. I was born in China and I lived in New Zealand for 15 years. Moved to Japan around 3 years ago, and I currently live in Hokkaido, which is the top part of Japan over there. And currently is around 2:30, 2:45 a.m. So I just woke up from a nap, but yeah. And I am the father of a 10-month-old boy, and he's on the right there, very cute. And I also help organize Tokyo Test Fest, which is a QA conference in Tokyo, Japan. And it's actually happening in the middle of November this year, and it's the second year that we're hosting it. And it has simultaneous interpretation, so it's catered for Japanese and English speakers, and most of the speakers actually speak English. But yeah, let me know if you're interested in attending this QA conference in Tokyo. A little bit more about my company. I work at Tier 4, which is an autonomous driving company based on open source software. We'll go more into details later, but we develop autonomous driving software for buses, robotaxis, factory carriers, and more. So different types of vehicles. And we also develop web apps to support the above autonomous driving development. So for example, we have a fleet management system to support the operations of the autonomous driving software. And we have in-house CI/CD products and services to help, build and test the autonomous driving software. So my team actually is the QA team responsible for the web apps that support the above autonomous driving software development. And yes, a little bit about the contents today for the presentation. First, we'll go into the web teams at an autonomous driving company. A lot of people I talk to really it's very hard to explain what the web teams actually do in an autonomous driving company, because autonomous driving really doesn't really have much to do with web and cloud. So I'll give you a little bit of context and background about the web teams at my company, and then I'll tell you about the problems that we face with our E2E tests and our solution with Cypress, and lastly, I'll explain why we use Cypress. So first, web teams at an autonomous driving company. Yes. So this is a very high-level diagram about what Tier 4 does. So at the base of everything, there's Autoware, which is the name of the open source software that does the autonomous driving. And it's managed by an organization called the Autoware Foundation. So this software is completely open source, and if you Google it, you'll be able to find source code and documentation and quick starts on how to run the software on your own local setup. But this Autoware, what it actually consists of is the core modules of the autonomous driving. So sensing, perception, localization, planning, control, stuff like that. So the common components for all types of vehicles is stored in Autoware, the open source version. And even though the Autoware Foundation is a separate entity to Tier 4, it is very tightly coupled, because one of the founders of the Autoware Foundation is the founder of Tier 4 and the current CEO of Tier 4. So even though they are separate entities, we have very strong relationships. And a lot of the employees at Tier 4 actually contributes to the open source Autoware on a daily basis. So yeah, that is the open source Autoware. One thing to note is that because it's the core components of the autonomous driving software, it can't actually be just used on a specific vehicle. For example, on a bus, you can't just use this open source version of Autoware because you need some level of calibration and integration for it to actually work on an actual vehicle, specific type of vehicle. So that's where the first department of Tier 4 comes in. It's called pilot.auto. So pilot.auto extends or forks off of this open source Autoware and develops solutions for our customers so that they can just use our software without too much calibration and integration. So, for example, they would develop bus Autoware or taxi Autoware or factory carrier Autowares, different types of Autowares so that our customers can just use them. So that's pilot.auto, the autonomous driving software development team. And on the right, there's another department called edge.auto. Edge.auto is the hardware development team. They develop hardwares, for example, sensors, cameras, lidars, any kind of hardware that or sensors that autonomous driving software needs to gather the data they need to make decisions. We develop those, and it is specifically designed for autonomous driving software, but there are also customers who are outside of the autonomous driving industry that purchase these hardwares because they are of very high quality. And lastly, but not least, I guess, is Web.auto, which is the team that my QA team is responsible for. Web.auto is a bunch of cloud-based tools that supports pilot.auto. So I'll go into more details on that on later, but it pretty much builds, tests, supports the operations, and collects the data from Autoware. So it helps the pilot.auto's dev team software development lifecycle. Yeah, and our customers can purchase Web.auto licenses like subscriptions, kind of. Yeah. So these are the three departments that make up Tier 4. And our customers come in all shapes and sizes as well. So for example, there are customers that just want the software, for example, autonomous driving software, and we would provide that to them. And there's also customers who, for example, want the software and the actual vehicle itself. So we provide the vehicle and the software as a package. But there's also customers who just want consultancy. They want to develop their own version of Autoware. Then they would just ask us for a consultancy and would provide services like that. So that's pretty much Tier 4 on a very high level. And next, we'll have a look at pilot.auto. It's not really my QA team's product, but it's easier if I could show you a video to show you exactly what the autonomous driving software looks like in real life. So next slide. Yeah, okay, this is a video. So the video of a autonomous driving bus driving in the rural town of Shiojiri in Japan. On the right is the simulations. On the left is the camera data. Well, not really simulations, but yeah, the perception data. So yeah, that's pretty much what pilot.auto software looks like. We have several instances where the autonomous driving is implemented. Oh, let me exit out this. Is implemented and actually collecting fees from real customers to transport them from place A to place B via bus, like a normal bus. So yeah, that's pretty much pilot.auto. And let me go to slideshow again. Okay, and then next is web.auto. It's a lot of information, but to understand our E2E tests, it's kind of necessary to kind of understand what web.auto is. So I find it easier to explain what web.auto does via this software development lifecycle that pilot.auto does. So pilot.auto is, again, the software, the autonomous driving software. So in this software development lifecycle, it starts on the left, development. And as an example, a new version of the bus autonomous driving software comes in, the bus Autoware comes in, developed by pilot.auto department. And that will come in the source of like, I don't know, like a new tag being created in GitHub. And that new source code will need to be built. And building it is actually kind of complex because it has a lot of dependencies, not just one repository. It has a lot of different dependencies, and it's kind of very long it takes a long time to build. It's a very huge ROS, robot operating system application. So it requires some specific environments to build smoothly every time. So we have our own CI/CD pipeline called Evaluator. That is one of the web tools that we provide and develop. It pretty much looks like GitHub Actions or Circle CI or any CI/CD tool that you guys are familiar with, but it is optimized in the backend to build Autoware on the cloud. So that is one of the web services that we provide. And another web service we provide is testing it. So after the Autoware is built and the binaries are produced, we have to test whether it still works properly. So what this testing means, and this test is not really done by our QA team, it's done by the autonomous driving side's QA team. There's actually several QA teams on that side, but this testing is creating simulation test cases. So for example, a regression test would be if you place a person in front of the car for this specific test case, the car should stop in front of the person, should stop, I don't know, 2 meters in front of the person. So regression test cases like that, they would use our simulators to make sure that the new version of the bus Autoware hasn't regressed or it's not bugging out. It's not going to just run the person over. So that's the testing part, and all of this is embedded inside the evaluator. So the evaluator would build the Autoware and run the simulation test cases to make sure that nothing has broken. So that's the simulator itself is also being developed by a web team. So that's another tool that we provide to the provide as the web team, web.auto. Then after the binary is being tested, we have to develop it, deploy it to the actual vehicle so that, for example, the actual bus can use the new version of the bus Autoware. And to do that, we have a fleet management system. So this tool is another web tool being developed by web.auto. And it allows you to perform over-the-air updates. So pretty much just like a wireless updates to the vehicle remotely. So yeah, it's another tool that's being developed by us. And after the new version of the bus Autoware has been developed, deployed, we would have to operate it remotely. And the operations is also being done by these two tools, the Fleet Management System tool and Remote Operations tool. So Fleet Management tool allows you to register schedules. For example, you want this bus to go from point A to point B at 2 p.m. every day. Then you would use this web tool to Fleet Management System to register those schedules. And you would use this Remote Operation tool, which collects the camera data from the vehicle so that the remote operator can see if there's any irregularities with the surroundings of the vehicle. After the vehicle operates for a bit, there will be bugs. Autonomous driving, there's so many scenarios, there's always some kind of bug. So for the autonomous driving software's dev team to fix those bugs, they will need to reproduce it. And to reproduce it, we need data. And there's a lot of data with autonomous driving because there's so many like trees, people, cars, everything needs to be collected. So that data is a lot of data, and we have another web tool, that cloud tool that manages it. It's a data management tool. It's pretty simple front end, mostly a backend tool, but yeah, it collects the data so that the Pilot.auto's dev team can replay the scenario or the buggy scenario that was collected from real life and make updates or bug fixes. And then based on those bug fixes, a new, for example, bus Autoware would be developed, and new source code comes in, and then the software development lifecycle continues. So yeah, on a high level, Web.auto is pretty much just a set of web tools that supports the entire lifecycle of Autoware. So yeah, that was a lot of explanation, but yeah, pretty much as long as you get the high level idea, it's okay. You don't really need to know what each product does. So now into the E2E tests a little bit more. So traditional web apps that are not from Tier 4, it's mostly front end and back end. But with Tier 4, the difference here is that there's an edge component. It relays information between backend and Autoware. So on the next slide is a chart. So there's the web front end, which communicates to the web backend as normal. But there's also the web edge. The web edge is not on the cloud. It runs on the vehicle. And it's an AWS IoT service that runs on the vehicle. And it communicates with Autoware via the robot operating system, ROS2. And it also communicates with the web backend. So it's like a just a middleman between Autoware and the web backend, so that they can communicate with each other. And if I'm sure everyone has had a look at the testing pyramid before, but with the edge component I just explained in mind, there's unit tests, integration tests, which is the same as everyone else, but there's E2E tests. It's actually split into two layers. There's the E2E test without software, which is pretty much mocking Autoware, and there's E2E with Autoware. So this E2E with Autoware is the main focus of this talk. Yeah, so this is testing the edge component, and this is testing without the edge component and without Autoware. So as you can imagine, there's a lot of problems, but the main problem is asynchronous release cycles. If you have a look, there's some kind of, this is on this slide is like the initial state. This is just an example, but an initial state of Tier 4's products. There is web application v1, so the first version of web application, and vanilla Autoware. So this vanilla Autoware is the Tier 4's fork of the open source Autoware, and the Tier 4's bus Autoware v1 is built off of the vanilla Autoware v1, and taxi Autoware v1 is built off of vanilla Autoware v1. And as we develop more features and have more releases, we'll eventually come to this state where web application has a v2 now, vanilla Autoware has also got a v2 now, and bus Autoware has also got a v2, which was built off of the vanilla Autoware v2 and bus Autoware v1. And taxi Autoware v2 also has a new version now, and is built off of the vanilla Autoware v2 and the taxi Autoware v1. So as you can see, the different types of Autoware kind of uses the common components every release, so that there's not that much duplicated development effort. But anyway, the problem is that we have to do a lot of testing. So for example, at this point in time, web application v2, when we're trying to release it, we have to make sure that it works with all kinds of Autoware. So vanilla Autoware v1, we have to make sure web application v2 works with vanilla Autoware v1, make sure it works with bus Autoware v1 and taxi Autoware v1. So even though these Autowares are built off of the same vanilla Autoware v1, there are still differences that could make it bug out. For example, bus Autoware has a lot of data a lot more data than taxi Autoware and vanilla Autoware. So that increase in data might cause some bugs with the web application. And when there is a new version of Autoware coming out, for example, vanilla Autoware v2 comes out, you have to make sure that it works with the web application v2. If there's a bus Autoware v2 comes out, you have to make sure it works with the web application v2, and same with the taxi Autoware v2. So there's a lot of points of testing, and the problem is that these asynchronous releases require too much manual testing to make sure everything works properly. And so we need to automate it. But the environment is very hard to prepare because Autoware is a big ROS application that takes sometimes hours to build. So it's very difficult to have the Autoware environment ready when you're trying to run the web tests, the Cypress tests. So in comes our CI/CD service evaluator. Pilot.auto's teams, the Autoware development teams, they use this to build and test their Autoware, as I explained before. But the upside is that it also leaves ISO images and Docker images as artifacts. So that is actually very useful for us. So the image says there's a Docker image, and Docker image is the one that we use for our E2E tests. And we can run those images on AWS because the Docker image is very easy to run. And so it is problem solved. So a little bit more details about the solution that we have developed to automate these Autoware E2E tests. So pretty much we use GitHub Actions and AWS to automate our tests. GitHub Actions authenticates with AWS by using OIDC to allow GitHub Actions to access AWS securely. And GitHub Actions pretty much uses the AWS CLI from the GitHub Actions for all operations to AWS. So pretty much all of these arrows pointing from GitHub Actions to AWS is using the AWS CLI. So if we look at the top left, test starts on GitHub Actions. So the trigger is always on GitHub Actions side. And we'll create the EC2. The first thing we do is create the EC2 on AWS. So EC2, for those of you not too familiar with AWS, is pretty much just a cloud computer. And we create the EC2 with AMI images and actually launch templates so that the exact same environment, the exact same computer, with the exact same network configurations and everything is created every single test. After that is done, we pull the latest image or whatever image of Autoware that we want to test from the evaluator. The image is pulled with evaluator's dev team CLI tool. The image is slightly modified with a Docker file to make it have the correct configurations to connect to the web. So what that mainly means is that the web edge component I talked about earlier, the edge component that runs on the vehicle, requires systemd to work. So our Docker file pretty much just installs systemd on the image from evaluator, because normally it's not really good to have systemd on your Docker images, but for our case we actually need it. So yeah, we make that modification and make sure that EC2 has the correct image with Autoware inside. And then back to GitHub Actions, we make sure that the image has been pulled properly, and then on GitHub Actions we start the Cypress tests. So Cypress tests, we would start the web tests, and an example of a test would be register a vehicle on the website and create a schedule and make the vehicle run on that schedule. So first we will have to prepare the web app, which is the red box right here. Once the web app is prepared, so this is pretty much like logging in and stuff, we would start Autoware. How we start Autoware is pretty much using site.exec and executing commands to EC2 via SSH. And we execute those commands via SSH into the Docker container to start Autoware. And once Autoware is started, Autoware can connect to the web with the edge component. And then Cypress, connections. It connects to the web with the help of AWS Greengrass, which is already something that you need to know, but it's not part of the test, but the part of the application. And at last, Cypress continues with the tests. So this is like registering the schedule and making the vehicle run, part of the test. So pretty much this setup is ran in the before hook or before each hook of every test. And what comes afterwards depends on the test that is being ran. Whoops. So here's a video of the tests running in action. So on the right is the Autoware, and on the left is Cypress running on the web. So on the left, this test is trying to register a schedule. You can see the vehicle is already just idle in Autoware. Yeah, so the schedule is being registered right now, and that should reflect onto Autoware. So I have to make sure that Autoware received the schedule correctly. And you can see that it received it because there's now a green route shown on the map now. And we have made we have told the vehicle to go, so it's currently driving. Yep, and the test pretty much continues until it reaches the stop point. And then after that, the test actually makes it go back to the starting position again, but we can just skip that. But this is pretty much like a typical test case we have, E2E test case we have with Autoware. We make sure that the web parts work, and we also use ROS commands to make sure that the state of the Autoware is correct based on the commands we send from the web. So yeah, that's that. Normally we run this all headless. So of course Cypress is always runs headless on CI, but the Autoware actually also runs on headless. This is just for demonstration purposes. We connected to the EC2 via VNC, and we're showing the GUI right here. But yeah, normally it's just showing with. Normally it's just run headless. I think okay. Okay, next a little bit about why Cypress. So the main reason is that there is test replays on Cypress Cloud. With complicated tests that needs to sync with AWS Autoware, it's crucial to be able to debug failures efficiently. So being able to see the DOM and the network requests and all of the AWS logs that we have is essential that we use Cypress Cloud's test replay function. This is actually very helpful. Like a colleague actually joined my team like a couple months ago, and he saw Cypress Cloud's test replay function, and he was like really amazed because he used to use Selenium, and debugging tests was a completely different challenge with and without some feature like Cypress, the test replay function. So this is one of the main reasons that we use Cypress. And I think other tools, we probably implement something similar if you try it, but everything out of the box just works with test replay. It's definitely one of the best features of Cypress, I would say. And access to node environment with sci.exec. So all of this stuff with EC2 would not be able to be done without sci.exec. So that's one of the other reasons. It ticks that box as well. And since we have a lot more developers than QA members, we have probably close to 50, 60 developers in the web team. And we only have around 5 well, actually around 8 to 9 QA members now. We can't have everyone writing tests for all of the web applications. So Cypress, being developer friendly with all the documentation and the syntax, is useful for cross-team collaboration. Right, and that's the end of my presentation. Is there any questions?
Hey, Chris, thank you so much. This was incredible. I think somebody in chat said it perfectly, that this is the most amazing test automation project I think I've ever seen. It's inspiring to see how it is used in testing out these self-driving systems. And I guess you could probably really say about your tests that they drive themselves. We have a couple of questions coming in from the audience, and I'd love to bring those up on stage. So I'm going to go ahead and share the first one. So this question here, I know you talked a little bit and showed your testing pyramid of like how Autoware fits in, but is there additional testing that you guys do in Autoware in the embedded system in the vehicle, and what kind of tooling are you using for that?
Oh yeah, the vehicle's embedded software is also tested, but that is actually mostly done by the QA team on the pilot.auto side. But they have like a bench set up in the office for testing things with the simulator and some hardware like cameras and sensors and stuff. And there is also a team that does actual testing on real vehicles. So the embedded testing is kind of more done on that side, and our team mostly deals with non-embedded stuff, like just running Autoware in a simulator and connecting to the web and making sure that part works. So the separation of concerns is there.
Nice. Another question from the audience is, how do you manage waiting for processes to complete in your test?
Oh, we pretty much pull the Autoware. If you're talking about the autonomous driving part, we have, I talked about the edge component of the web application. We actually have a similar component for the tests. So at the start, we copy a bunch of files onto the EC2's Docker container with Autoware running. And one of the files is like a interaction module that interacts with ROS2. So we use that module to pull the topics from ROS2. I mean, topics is kind of like for robot operating system. It's like the robot operating system always gives out a lot of topics, and we wait for the certain topics. For example, for the vehicle to be ready, there's like a vehicle state topic that we wait for. And for example, if we're telling the vehicle to drive, then we wait for that state to be in the correct state before we drive it, make it drive. Yeah, so mostly with ROS2 topics.
Okay. And then another question here, just curious, how long does your CI/CD pipeline run to build the applications and run all the test cases?
Yeah. So for this test, we actually only started doing this like a year ago, but for one test case, it takes around 50 minutes to run. Most of the stuff can, most of the wait time is in the pulling the image from the evaluator part. So it's the Autoware image is really big. It's like 60 gigabytes, and you have to pull it, and then you also have to extract it. So the extraction actually takes a lot of time, even though we're using a very high spec EC2 right now. So we're trying to optimize that process by this financial year. We're trying to optimize that process by first storing the caching the EC2 in our own AWS account, because the evaluators team's AWS account is not actually the same AWS account as the tests that we run, because there would be security concerns. So caching the image itself, and also to speed up the extraction of the Docker image, we're trying to maybe cache it in some kind of EBS storage thing, and then we can just load the EBS onto new EC2 every time, so we don't have to extract it every time. So we're trying to improve on that. But right now, it's just mainly for super high priority test cases, and it runs for quite long, like 50 minutes.
Okay. One more question here. Going to share this on screen. We know it might not be possible, but man, you have all of us hooked on how cool of a use case this is. So is it possible for you to show one of your Cypress tests? And if so, go ahead and share it on screen. You got the screen share.
Okay. Let me see. Just open one of the. I mean, the tests themselves, they are not really that different on the high-level test case file. Let me just. Yeah. Okay. Let me just share my screen for that then. How do I? Oh, wait, there it is. Yeah, I mean, it's not really. You probably can't really tell much from this, but it is a kind of like long test case. But there's special methods we have. For example, get vehicle position that connects directly to ROS2. The test case itself is kind of long, but yeah.
That's awesome. No, we appreciate you giving us a preview there, Chris. So thanks for showing that.